So let's go through these exit ticket questions that you were given. For this first one here, you're told that these triangles are similar, and you're to find the value of the variables. Now, as far as x goes, you can see because of the way it's positioned, um, x is in the same position as the 30-degree angle. I can tell which sides are shorter and longer, and so it's opposite the side, that we're comparing as well when we eventually figure out um, what the sides are going to be. So it's in the same position as the 30-degree angle, so x is going to be 30 degrees. As far as the y value goes, when I compare corresponding sides, I'm going to have y being compared to the 2.5, just like 8 is going to be compared to the 5. So I would set up a ratio of y over 2.5 equaling 8 over 5. Always make sure that you set up your ratios going from, the one triangle to the next. So this one I'm always doing bigger to smaller. And when I cross multiply, I get 5y equals 20. And then when I divide both sides by 5, I get y equals 4. For the next one you were given these two triangles. No angle measurements, all side measurements here. Now you can tell that the 7 side is comparable to the 3.5 side, and they're orienting them the same way at this point. As we go through this unit, that's not necessarily going to be the case, and sometimes you have to verify that scale factor as you go along. But 7 and 3.5 are the corresponding sides. The x plus 4 and the y are corresponding sides, and the 3y and the x are corresponding sides. So one of the things I have to be careful about how to do this is, I could set up equations here that I may not be able to solve. For instance, if I do 3y over x equals x plus 4 over y, I'll have two variables in that equation. It'll be very difficult for me to solve. So it's always a good idea for me to locate and find the one point, or the one piece of information that is known in both triangles, especially when I'm setting up the ratios. So I'm going to want this ratio involved in both my calculations to make calculations a lot easier. So I'm going to do the 7 to 3.5 in both the ratios when I set up to find x and y. So one of the ratios I can set up doing that. And I'm doing a big versus small. So the scale factor is 7 over 3.5 or 2. So I want 3y over x to be 2. And I want x plus 4 over y to be 2. So in this case here, I can, I still have two equations with two unknown values, but at least I have equations now that I can actually solve. So 3y over x equaling 2 means that 3y is going to equal 2x. X plus 4 over y equaling 2 means that x plus 4 is going to equal 2y. And I could turn that equation into saying x equals 2y minus 4. And what you're seeing is that I do substitute that value in for x when I get down to the third line of my solution. Because now I could solve for y to figure out that y equals 8. And then I could go back to one of those two original equations. And I went back to the fact that 3y equals 2x. I plugged in 8 for y. Got that 2x equals 24, which means x equals 12. So I did have to solve a system of equations, but if I had set up the ratios incorrectly, I would have had only one equation with two unknown values set up, and that would cause a great deal of difficulty. For the next couple questions, you're asked about scale factor. Now, if you're doing a scale drawing type question, you don't necessarily have to have the units being the same. If you're trying to do something that's going to compare, like a projection or something like that, that's where it sometimes comes in handy to have them the same. So this one here, so as long as I realize that, 15 centimeters represents 120 feet on, from the drawing to actual building, I'm good. I don't really need to convert, one to the other. So if the scale drawing is 45 centimeters tall, how tall is the actual building? So when I set up the ratio, I'm always going to want, I'm setting it up from drawing over actual building. So 15 over 120 should be 45 over the actual height of the building. And then if I cross multiply, ignoring the units at this point, I get 15h equals 5,400. And then if I divide both sides by 15, I get that h equals 360 feet. So always to be careful that you are aware of what the unit of measurement should be and the thing you're looking for if you're not converting them all to the same unit. For the last question you were given, what if the scale drawing of the building was 57 centimeters tall? So again, I'm going to set up 15 centimeters over 120 feet, but now it's going to equal 57 centimeters over h. Again, I'm going to cross multiply and get 15h equals 6,840. And then when I divide both sides by 15, I get h equals 456 feet. That's all I have for this. If you have any further questions, please contact me or your geometry teacher. Until I see you in live lesson, have a good day.